So hi everybody and welcome back to C++ tutorials for absolute beginners. This is video 277, and in this video we continue of course with our exercise again, and like old time, pause the video, read the question, try to answer it as good as you can, and then compare it with my answer, and of course then compare it with the original site here, and we get started. First of all, it says here, create an abstract class and explain what abstract class means. And of course, I will not pause the video and I go straight to my example. First of all, I show you my abstract class example. It looks like this. So we have here a normal class. It's an abstract class. It's like a normal class. The only difference is that you are defining a pure virtual function, and the signature looks like this. All right, that's the creation of our abstract class, but of course you should also use this abstract class. And how we use this, so of course we inherit from it. So because an abstract class means you can't create an object for about this one. So if I try to create an object like I try here on the bottom, let's call, what was the name of this again? Funny person, my funny person. Let's try to create a funny person object. Funny person, it's me, and you see I can't do this because it's abstract. We are not allowed to create this one. All right, that's very nice. And then let's go up again and talk a little bit more. And of course, this is a pure virtual function. And you see the signature is that you make here this equals 0. So if you find in a class one pure virtual function, it is necessarily only one with equals 0, then it's automatically abstract and you have to, and you can't create an object of it. But you can inherit it, of course. And you can see here in my class fun, which is not abstract, I inherit this one, and then I can implement this abstract class. I have to implement it if I want to use this fun class to create an object for this fun class. Of course, I can say this fun class should also be abstract, and I just don't implement this one here. I can, for example, here I have this print name. Here I have an implementation of it, but I can say, hey, wait a minute. Let's say you are abstract too, then I make here equals 0, and you can see this one becomes automatically abstract too, which means if you try to create objects now with the other ones, you can't create them, and then you have to inherit again. So you can make this, but I'm not going to do this, so I keep this one. And then let's go here to the question again. It says here, create an abstract class and explain what abstract class means. So it means just we can't create, but we have to be careful. We will see a little bit more. Let's read the second question. And here it says here, what is a concrete class? It's very easy. If this is an abstract class, which means you can't create an object, a concrete class means you can create an object. That's more it. There is not much to it. And a concrete class means I can create an object, which means every class which we created so far, which is not an abstract, is a concrete class because we can create an object. And that was very easy, I think. I hope that's not so very difficult. Important is here they use here this word concrete sometimes in the description, that you know. What is a concrete? Concrete class means just you can create an object. And most time it means also it is used with abstract, which means here in my example, this one was abstract, then I derived from it, and then I implement it in the derived version, and now this one is concrete because I can implement this. I can create an object and have the implementation from an abstract class. Sometimes it's used in combination with that one. All right, so let's go to the last question here, and it says here, write for your pure virtual function a definition in the abstract class. And here, that was this again, my pure virtual function, my abstract class, and I should write, and it says here, I should to write a definition in the abstract class. Oh, wait a minute. And a second definition in the concrete class. Okay. And then it says here, is this allowed? If not, explain why. I hope you tried this and understand this. So I show you my solution. First of all, is it allowed to write here a definition? And the answer is no. You are not allowed to write here in the class itself a definition where this equals 0 is. There you can't write a definition. But you can implement the definition in the derived class. For example, you can see I derive from it. Here I override the virtual function call, and that is allowed. But now we have to read the question here a little bit more careful. I said here write for the pure virtual function a definition in the abstract class. I can still write in the abstract class a definition, but not in the class, but outside of the class, which is considered still connected to the abstract class. And this is a little bit confusing because many will say that's not allowed. Careful, you are not allowed to write in the class a definition. You are allowed to write outside a definition, and this one is then called and then this one is a default value and means it is not for the abstract it's not for the pure virtual function definition. It's a let's call this one here to make it clear, for non virtual function call. So that's very important. This one is for the non-virtual function call, and the problem here is with this one, it is both in one. So it has here two functionalities, and many forget this, which means normally what you use is here the pure virtual function, which means this class is abstract and you can't create an object, and then you have to implement this in the derived class, and that's the normal way. But like I said, this you can, because still this is a virtual function, it is just pure. You can just say I call the non-virtual part, which means this part, I skip the virtual and I skip this one here, and then you can make this default call. We talked about this one as well. I hope you remember this one. You can call the base one, and that is similar to the non-virtual version of the virtual function. And this one works here with pure virtual 2. So, and let's see an example here in my case to make it a little bit more clear. I have here some examples. First of all, I have here a base fun class. This is, oops, not this one, sorry. Base fun class. Oh, it is base fun class. So the base fun class, not so. Is that this one? Yeah, whatever. So the base fun class here is my fun, a class for fun. So let's see this one, it's fun. And here I call print name, and you can see this print name I have implemented. This is my concrete class now. Let's here print name, I have it from my abstract class. That was my funny person. You can see I have here public inheritance, and here I implemented this one. So you see it is still a virtual function. I use override again to indicate I override this one here, and then I call this one. But interesting here is this one, what I did here is a direct call. What I mean with direct call, base fun class, you can see, is just a fun class directly. So it has nothing to do with virtualization. I created a fun, and then I called this print name here directly. But now let's go here a little bit more. You can see fun with games print name. So let's go here, fun with games. What is that? Fun with games. This is a games part, and this one is the other one. So that was fun, that was games, and here I have print again, and I override here. And interesting is about this fun with games. Let's see. Is this also directly? Yes, this is also directly called. So these both are direct call. That is not really using virtualization. But let's go here one step further and use virtualization, which is my PTR base fun class 2. So you can see my PTR fun class 2 is this one. You can see it's a pointer from fun, and I'm pointing to fun with games, and fun with games is games. So we are pointing from for this games is assigned to fun, and of course it is here not a pointer. Here it was a pointer. Yes, that was a pointer, and then I call print name. But important is here it is using virtualization this time. Why it is using here virtualization and here not? Because here we have a fun base class, and then it calls fun first, and then it tries to check every final override with this. So it starts here with fun. It says here, okay, here's a print name. All right, nice. Oh, there is also games print name override. Oh, that works too. This is the final one. I use this one. All right, and then so then one more thing. Let's see if this works so far. When I start here, this one. So the first one. So this here, the first one is the normal calls. The third one, I think, is our virtual call. That was the pointer. Or there's something wrong. Let me see. Ah, no, that is just a definition. Oh, okay, okay. That's fine. So this both were direct calls. This is virtual call, and here is my non-virtual call. I told you before there is this non-virtual call. So I created here in my fun person. This fun person is my abstract class. You must see it when you see this one here. But we said you can't create an object, right? But look what I have here. What I made here. It is not an object, but I have a reference. That means I can still create a reference. And then I pointing to my fun class. This is like our disk. Also we are assigning this one here to this one here. So that is still possible. You can see that works, is allowed. And now I can call with this here, my non-virtual function call. That was that you call the name here, and then the abstract class here, and then the function. That is that. So you can see here's the fun person, then I call the print name, and this one is going to use now the default value here, this implementation from here. So you have to be careful about this this non-virtual function call. As a beginner, you should not care too much. This default value here is almost never used, because normally when they declare a normal function, I mean a pure virtual function, the intent is that you have to implement this in the derived class. This is the reason why you make this. This default here is not so much used, because many are not interested in a non-virtual function call, because you can solve this easy without another function which is just a normal function instead of calling the non-virtual function. So you can avoid have two things in one. And there is this one rule. Remember, you should not have function with more responsibilities, and this is, you have here two different things. That's not so easy. That's why as a beginner, just concentrate on this one. And everybody on the net is anyway saying, if you are declaring a pure virtual function, you can't create a definition. But careful, we still have to learn this kind of stuff, because if there is a bug and you are facing a code who is using this default value, that you know what this is. All right, I think that's it for this demonstration here. One start, and you can see indeed I'm calling my definition. This is an implementation in the abstract class. That is this one here, which I have defined outside. You can see the non-virtual call is working with this one, what I showed you here in the last line. And I hope you tried this on your own too, created this one, tested this one a little bit, but because the theory is nice, but yeah. But one more thing, perhaps we should watch here again this documentation, because our goal is to understand this documentation. And my example is similar to this one. You can see I go fast through it now because you should get a little bit used to it now. So you can see abstract class. When you see here this pure virtual function, it's very important, this equal sign. And then when you have here class, you can see the structure is defined, normal virtual. This is just a normal. And then here is this virtual function, pure virtual function. We have here one here. Here they are changing the non-virtual function, the normal virtual function to a pure virtual function. That's also possible. Keep that in mind. What they are doing is, for example, here in my example, I'm overriding it here. Here is pure, right? So it starts with the abstract class. Then it becomes a concrete class because I make an implementation. But like I said, in the next, if I want, I can go and make this one pure again. So, which means this one becomes abstract as well if I want. I don't have to override it. And that's more or less what they are doing. They are even different. They have here an implementation, I mean, a normal virtual function, and they convert it to a pure virtual function, which means they make this base here abstract. Yeah, and then let's see, and they have here destruct abstract, but here this kind of stuff you should only do if you are a little bit more advanced, because the destructor has only one job. We learned this, which is just clean up. You should not customize this one if you have no clue, or you can make some bugs there or leaks or something like that. But anyway, you know that this exists. That's very nice. And here we have again a virtual function, a pure virtual function. And this one is not allowed. You can see error because, like I said, a definition inside the class is not allowed. That was this one, because in the web they are referring all time to this one. They're saying inside it's not allowed. Like I said, in my example, inside I can't do it, but outside you can see this one is this one. I can. That's very important that you keep this in mind. And yeah, you can watch this one. I hope you can see this now instantly. Here you see the 0 abstract. You see here's an override. Okay, virtual G, then concrete, this name concrete, and so on. And here they make it again abstract. So this one is concrete, then they make it abstract because they are overriding this G was here to 0 again. And then you can check this a little bit here. So on. I hope you see this one. It's very easy. Let's go here fast too. So you can see instantly, don't have to read this. Abstract is, by the way, just a name. Careful. They can irritate you. They write here abstract, but abstract is this one here. You have to find this virtual function, pure virtual function call. And this one you should avoid. Like I said, never call a function in a destructor, because destructor's job is just clean up this object which was created, and so on. So make free memory the compiler's job. Don't call here other functions and so something like that. This is just for demonstration purpose, for advanced people who know what they are doing. And let's see what we have here. Okay, and so on. I think the other things you are very easy. Then here is one more thing. This suppressing, like I said, this virtual function, this one again, this virtual function has two functionalities. When you read virtual void print name, the first is just a virtual function, and then you still can call the non-virtual function, this one here, and this is called here the suppressing virtual function. Here is again how you suppress this if you want to read this again. And I think that's it for this video. So I hope you understand also far, and with that said, have a good time. See you in the next video. Bye.